Okay.
This is route summarization. So what is route summarizations? Route summarizations means you actually summarize the route. Like for example, multiple subnet you have, but if you can summarize all the multiple subnet to one subnet, in this way, the routing table will be smaller. So some context, we actually require these stuffs, and routing table has a lot of benefits, so which we're going to talk about now. If we have a big routing tables, it actually consumes memory in the routers. Routing requires to match a route in the routing table. Searching a longer table takes more time and more CPU cycles. Routing protocols require more work to process the routes, more bandwidth to advertise the routes, more time to troubleshoot the problem. So solution is route summarizations. So route summarizations means, let's say we have many subnets, 1.0, 2.0, 3.0, 4.0, and so on. So what is route summarization is saying, we can advertise one simple route such as 172.16.0.0/16, which contain all other small subnet in here. In this way, when we advertise, instead of advertising 10 different subnet, maybe we can advertise only one subnet, and it will be helpful for the router. It will be easy for router to process the route. So it allows engineers to configure routing protocol to advertise one route, replacing several small routes. This process creates summary route that matches the same range of addresses as the original. So route summarizations and IPv4 subnetting. So subnetting plan should be designed with route summarizations in mind. For example, 10.2 subnets on the left and 10.3 on the right. This kind of subnet placements make route summarizations easier. So if somebody make a route summarizations like that, like 10.3.4.0, 5.0, 6.0, 7.0, then he can do some summarizations. Or if somebody do like that. But if somebody do like different, like this is 10.1 something, another one is 11, another is 12, something like that, then you'll not be able to do the summary route. So it is important, and it's related with subnet design. Now, if we looked at this routing table, R3 routers is advertising 10.3.4.0, 10.3.5.0, 10.3.6.0, and so on. So if it is advertising 4 of them, and if we looked at the R1 routing table, we'll be able to see that 4 routes, right? But if we do the route summarizations, then what will happen? Instead of looking at 4 subnet, we'll be able to see only 1 subnet. Still, this 1 subnet contains that 4 subnet, but this is kind of like just a summary route. So this is very handy, but we're going to learn how to do the route summarizations. So let's have a look at this example. If you want to create route summarizations, it's only possible if you have a proper subnet design. Like if somebody make a proper subnet in here. Now we can see 10.3.4.0, this is one subnet, 5.0 another subnet, 6.0 another subnet, 7.0 another subnet. So what is the broadcast for 4.0? It will be 10.3.4.255, 5.255, 6.255, 7.255. So we need such a subnet ID that will cover from 10.3.4.0 to 10.3.7.255, right? Entire range it will cover. Now, if you have, this is our subnet ID, and this is the mask, subnet mask. So first thing what we'll do, we'll take the smaller number, which is 10.3.4.0, and we try with less prefix, such as 24. Already we know the result. We want to try with /23. If we have /23, then we say 255.255.254.0. Right? /23 means 254. 8-bit, 8-bit, 8816, and you have another 7-bit. 7-bit means 254. If you add the 7-bit values, it will be 254. Or you take 255 number and minus 1, because you have a 1-bit less. So first thing, 256 minus 254 equal to 2. This is my magic number. Magic number we need to compare with number 4. So 2 times 2 equal to 4. So it's matching. So 4 is our subnet ID. So 4 plus magic number minus 1 equal to 5. That is my broadcast IP. So this 5 I'm going to put back. So 10.3.5.255. So this broadcast address is covering until here. So that means this is it doesn't meet our requirements. So what we'll do next, 10.3.4.0, we're going to try with /22. So if we take an address 10.3.4.1, then 255, 255, 252.0. If it is /22, that means we have 6 bits. 6-bit means 252. So 10.3.4.1, and this is the mask we get based on this prefix. So now we get 10.3.7.255. So 256 minus 252, we'll get a number called 4. 4 we're going to multiply with 1, because 4 we're going to compare with this 4, because oops, yeah, this one, this is our interesting octet. Just make it color so it will be easy for us to understand. Oops. Yeah, so this is my interesting octet. So what I'll do, 256 minus 252, I get a 4. 4 I'm going to compare with number 4. So if I multiply with 1, I get 4. So 4 plus magic number minus 1. This is the formula. We get 7. So 12.10.5.0/24. Oh no, this is the different one, but number 7. So what we'll do, number 7 we're going to put back in 3rd octet, and this is the broadcast address. So we can, this broadcast address will be this one. So we can see that this is the right summarizations, and this address cover 10.3.4.1 to 10.3.7.255. So that means it is covering the entire range. Right, so this is the proper, this is the proper route summarizations, this one. After that, many different protocol like OSPF, EIGRP, over there we're going to put this summary address. But how to do the route summarization, this is important, and that is, so that is the important part we need to look at. When main thing is route summarizations will work only if someone make a nice subnet patterns. Only on the time we'll be able to do the correct route summarizations.
Yeah.
Okay, and this is another example. This one exactly same thing has been done.
So you have to find out what's the correct prefix
Summary.
that will contain the whole subnet.
Correct. Yeah, we need to find out a such a number, such a subnet ID that will cover the all small subnet.
Yeah.
This is another example has been done in same way. Tried with, you can see /23 didn't work, /22 didn't work, /21 didn't work. Oh, /20 this is work. So some cases we need to do a bit more, mathematics, and in this way
Yeah.
we need to find out. So that's pretty much the route summarizations informations.